look at this. Calculate the delta H reaction for chlorine, dichlorine in the gas phase going to chlorine plus chlorine minus in the gas phase using the bond energy of Cl2, the first ionization energy of chlorine atom in the gas phase, and the electron affinity of chlorine atom in the gas phase. This is a Hess's law problem, but in order to solve it, you need to use information from Chapter 8. So this is the target equation. Cl2 gas goes to Cl plus gas plus Cl minus gas. And delta H equals, we don't know. So we need reactions that will add up to this reaction. Okay? And information that we have, the bond energy of Cl2 is 243 kilojoules per mole.
Are we going to be given these?
Yes, you're not expected to memorize those kind of numbers. You'll be given those if you had a question like this. The IE1 for chlorine is 1256 kilojoules. And A1, the electron affinity of chlorine, is negative 349. So those are numbers that you would have to be given or be able to look up. So the question is, how do we put this information together to make equations that will add up to this equation? So let's start with the bond energy of dichlorine. Okay? The equation which corresponds to that bond energy is Cl2 molecule, diatomic, splitting up into two chlorine atoms. Okay, delta H is equal to the bond energy, and this would be a positive number because we're breaking the bond, of Cl2, and we saw that is 243 kilojoules. Okay, so we've got the chlorine that we need in the target equation here, dichlorine that is. But we have two chlorine atoms and we need to get rid of those. So we need an equation that will get rid of one of the chlorine atoms. And we also need products over here, Cl plus and Cl minus. So the first thing we can do logically is to take one chlorine atom and ionize it. We'll have to put in 1256 kilojoules. That'll make Cl plus in the gas phase plus an electron, and the delta H equals IE1 of chlorine, and that's 1256 kilojoules. Okay, so we got rid of one chlorine and we got to Cl plus, and we have an electron over here. So what we can do is take the other chlorine atom that we have from these two here, add the electron to that one, which will make Cl minus in the gas phase, and delta H for that is the electron affinity of chlorine, which is negative 349. Now if we look at this, inspect it algebra-wise, two chlorines cancels two chlorines, and then we add Cl2 gas goes to Cl plus in the gas phase plus Cl minus in the gas phase. And the delta H then would just be the sum of these. We didn't have to change anything around or anything like that. It would just be the sum. And when I did it, I got 1140 kilojoules.